Hello, welcome to IBCC channel. In this video, we will talk about the OSPF LSA refresh time and LSA maximum age. In previous video, we talked about the LSA types in great detail. However, we didn't mention how often the LSA can be sent out and how long the LSA can live in the linked state database. So LSA refresh time. LSA refresh time is the maximum time between the distinct originations of the only particular LSA. If the router's self-generated LSA reaches the LSA refresh time, a new instance of LSA is originated, even though the content of LSA will be the same. The value of the refresh time is set to 30 minutes by RFC standard. Here, by the way, the Juniper network implementations refreshes LSA every 50 minutes. Cisco implementation of the refreshes LSA every 30 minutes. So here's the question: why the LSA need to be refreshed? So there have two reasons at least. One reason is it can keep the network up to date. Second reason is each LSA have a maximum age. LSA maximum age. The maximum age is the maximum time an LSA can attend in a linked state database. When an LSA age reaches the maximum, it is reflooded in an attempt to flush the LSA from the routing domain. The value of the LSA maximum age is set to 1 hour. In particular, maximum age LSA is removed from the router's linked state database as soon as 1. It is no longer attend on only neighbor link state retransmissions list, and 2. None of the router's neighbors are in state exchange or loading. So this means from the router's perspective, the router there's two kinds of LSA. One is self-originated LSA. Another LSA is received from his adjacent neighbor. So if his received LSA was not get updated and he reached the maximum age, they will be removed from the linked state database. So method of the approach to refresh LSA. So the most straightforward approach to refresh LSA could be have a single timer firing every 30 minutes and cause the re-origination of all self-originated LSA. This method proved itself as a non-scalable solution and causing periodical CPU and link bandwidth exhaustions in network. Then how about have a separate timer for each LSA? So have a separate timer for each LSA isn't sufficient. So what is a good method? So optimize the method of the implementing of the LSA refreshment is called LSA refreshment dispersion. So optimize of the LSA refreshment process is if the first refreshment interval is randomized rather than set exactly to the refresh time. The subsequent LSA refresh will also dispersed. If the LSA are refreshed using individual timer, randomization of the first interval of the self-originated LSA prevents LSA refreshment event from grouping and cause network injections. The effect of the LSA refreshment dispersion is that OSPF do not put a high load on the network. However, maintaining a separate timer for each LSA can be very costly. A simple way to resolve these issues is to group the LSA that must be refreshed approximately at the same time and maintain a single timer for them. This is implemented by have a LSA accumulations group and a periodic timer. A LSA group is used to list all LSA originated between the two consecutive timer expirations. The group is flushed either on the timer expirations or when the size of group reach a predefined limit. When the group is flushed, a LSA refresh event is scheduled. The refresh event is dispersed by user LSA refreshment dispersed methods. Yeah, this is a good method to implement in the LSA refreshment. Uh, right now, the most vendors is pro is implement this method in his product in the OSPF. So if this video is helpful, please give a thumb up. Thank you for watching.